Hello friends, now I am going to solve another problem from physics section, and here is the problem. Two masses m1 and m1 which is equal to 5 kg and m2 10 kg are connected by an inextensible string over a frictionless pulley. Here are two discs m1 and m2 which are connected by an inextensible spring, and this pulley is frictionless. They are moving as shown in this figure. This is going down and this is moving towards right. The coefficient of friction of horizontal surface is 0.15 and mu, which is coefficient of friction, is equal to 0.15 in this case. The minimum weight m that should be put on the top of m2 to stop the motion. The minimum weight m that should be put on the top of m2 to stop the motion is. Here it is asked that what minimum mass m must be placed on this block of mass m2 to stop this motion. Now let's write free body diagram. Now let's draw the free body diagram of this mass m1. This is m1. Downward is its gravity m1g and upward tensional force. As it is going in the downward direction, acceleration is in downward direction. So the forces which act in the downward direction must be taken positive, and force which are opposite to the direction of acceleration must be taken negative. And we'll write net F net is equal to m1a. So now here m1g minus t is equal to m1a. This is one equation which implies m1 is 5 kg, so 5 into 10 is 50 minus t is equal to 5a. This is the equation, and similarly we'll also write the equation for mass m2. And suppose law bigger one. And suppose let's put a mass m to stop the motion. Let the minimum mass be m. Now in this direction is the tensional force, and frictional and gravitational force acts in this direction, m plus m2g. Normal force is in this direction and frictional force is in this direction. Let it be mu n, where n is normal force, and acceleration is in this direction. So here let's balance the vertical component. N balances m plus m2g. So let's substitute here, and here uh, t minus mu n is equal to ma, and here from this equation n is equal to m plus m2g. So t minus mu into m plus m2g is equal to this m2a. Given if we put this minimum mass m, they are at rest, which means they are not accelerating. So this a must be equal to 0. Again I am writing this equation here. 50 minus t is equal to 5a. For the blocks at rest, a must be equal to 0. So 50 minus t is equal to 0, as a is 0, which implies t must be 15 Newton. Again I am substituting the value of t in this equation. So 50 minus mu is 0.15, into m. We need to find the value of m, and m2 is 10 and the value of g is 10 is equal to 0, because a is 0, so m2a is 0. Now 50 is equal to 0.15 into m plus 10 into 10. 10 5 5 is equal to 0.15 into m plus 10. 500 is equal to 15 into m plus 10. 500 by 15 is equal to m plus 10. It implies m is equal to 500 by 15 minus 10, which is nearly equal to 27.3 kg. Thanks for watching. I am uploading solutions to all the questions, all the remaining questions. Keep watching. Thank you.